Okay, starting at number 10 on the review. So with 10, we're working with the Triangle Sum Theorem. Okay, the Triangle Sum Theorem says, if I add all of the angles up in a triangle, they will always equal 180 degrees. So for A, we have a 30-degree angle, plus we have this little angle down here, which represents a 90-degree angle, plus our 19x plus 3, and that is equal to 180 degrees. Again, your simple equation, you're combining your like terms. So we have 123 plus 19x equals 180. We're going to subtract the 123 from both sides because those are like terms. 19x is equal to 57. Divide by 19. X is equal to 3. Okay, it says use the triangle sum theorem to solve for the missing angles. So I have my x value of 3. We're then going to take the 3 and plug it back in to find the missing angle. 19 times 3 plus 3 should equal 60 degrees. So your missing angle is 60 degrees, which we could have said because 90 and 30 adds 120. 180 minus 120 is 60 degrees. Okay, for B, we're doing the same thing. All 3 angles added together has to equal 180 degrees. So x plus 13, which is one of the angles, 2x plus 7, and 5x all together have to equal 180 degrees. Combine your like terms. So here are all my x's and here are my numbers. We have 8x plus 20 is equal to 180. Subtract 20 from both sides. 8x is 160. Divide by 8. X is equal to 20. Again, we're going to take that 20 and substitute it back in to get these angle measures. So this is 5x, or 5 times 20 to give you a 100-degree angle. This is 2x plus 7. 2 times 20 is 40, plus 7 is 47 degrees. And x plus 13 is equal to 33 degrees. Again, if you take a look at all 3 of these angles, if you add them up, they should equal 180 degrees. Next problem, we are going to take all 3 of these angles right inside the triangle, and we are going to say they all add up to 180 degrees. We can work backwards, so we can say 180 minus 58 minus 23 is going to give us that missing angle measure that you guys see inside there. Okay, so 180 minus 58 minus 23. Okay, so I'm getting 99 degrees. That means that this missing angle inside the triangle is 99 degrees. Okay, we have to do one extra step now. This angle is, again, that's my windshield wiper angles. Those are supplementary to each other. So once I have that 99 degrees, x plus 99 has to equal 180. When you subtract 99 from both sides, you get x is equal to 81 degrees. Okay, again, the triangle sum theorem, all 3 angles inside of a triangle will always add to 180 degrees. Next, we're going to work with area. So it's up to you. This shape for A is a trapezoid. So I have one pair of parallel sides, okay? And so this is referred to as a trapezoid. So in order to do the area of a trapezoid, we need 1/2 base times height. The problem is we don't have, 1/2 times height, base 1 plus base 2. So this is the area of my trapezoid. The problem is we don't have both bases. So we're going to have to use some things that we know to figure out how big this base is. So I see I have another shape inside here. I see that I have a rectangle kind of attached to a triangle, which is also trying to make this nice. It's not moving up for me. Okay. There we go. So that's good enough. Because this is a rectangle, I know that this is 7, so this is 7, the left side is 13, therefore the right side is 13. So I can also find the area of this rectangle and add it to the area of that triangle. So those are two different options you have to do the same problem. Again, we still can't find the area of this triangle because I'm missing the base right here. So lucky for us, this is a right triangle. So we're going to have to use Pythagorean theorem to find that missing x, okay? It's leg squared plus leg squared equals hypotenuse squared. The legs are touching this right angle. So leg squared plus leg squared is equal to hypotenuse squared. 49 plus x squared is equal to 81. We're going to subtract 49 from both sides. X squared is equal to 32. Take the square root of both sides, and my x value is equal to, let's take the square root of 36. I want it to be square root of 32, I want it to be as accurate as I possibly can. So the square root of 32 is approximately 5.66. Okay, so again, that just gives us our missing part of the side. Now again, if you guys are interested in finding the area separately of the rectangle and the triangle and adding it together, it is the same thing as finding the area of the trapezoid. Okay, so I will show you guys both ways. So the area of the trapezoid would be 1/2 times the height, which is 7, times base 1, 13, plus base 2. Here is your base 2, which would be 18.66. Okay, so, and again, you guys would just type this exactly in your calculator as you see it. So 0.5 times 7 times 13 plus 18, 31.66. Okay, so I'm getting 110.81 units squared. If you wanted to go the separate route, you can find the area of the rectangle by doing 13 times 7. Okay, 70, 21, 91. And then finding the area of the triangle. So I feel like a lot of you guys might be more comfortable with this. So that one is 1/2 times the base times the height. And when you get that number, you have to add the green and the pink together to equal the total area of the figure. Okay, so again, 1/2 times the base times the height. And I am getting 19.81. Okay, when I add these two together, when I add that rectangle and triangle together, I'm getting 110.81. Either way you do it, using the area of a trapezoid formula or splitting it up into two shapes, you will get the same answer. Okay, for B, I'm going to split this up again, and there's plenty of different ways you can do this, as I showed you in the first one. Okay, I'm splitting this up into 3 rectangles. This is how I saw the rectangles. Could you have split the rectangles going this way? Absolutely. Okay, so I'm going to find 3 different rectangles. So the first one has a base of 2. So the area of the blue rectangle is going to be 2 times 8, which is 30. 2 times 8. Oh my gosh, I wrote the answer. 2 times 8, which is 16. I'm going to find the area of this pink rectangle. Okay, so here's the problem. I have the 5. I just don't know how tall this is. So I'm going to be using some subtraction. If you notice, this 2 right here, this is 2. Because this entire side is 6, I would have to do 6 minus 2 to give me this height of 4. So this would have to be 4 over here. Okay, so again, I'm noticing that the height of this side is 6, therefore the height of this side has to be 6. 2 plus 4 is 6, so that's where that's actually coming from. Okay, so to find the area of this pink rectangle, I'm going to do 5 times 4, which is 20, and then we have the area of the green rectangle. Okay, so that would be my 3 times 6, which is 18. Again, the full sides you can see that I'm using. I can circle the sides that I'm using so you guys can see which numbers and where they are coming from. We're not finished yet, so what we have to do is we have to add this up. So So let's see, 2, 4, 54. And again, this is area, so it's units squared, 54 units squared. C is just a simple triangle, so it's 1/2 base times vertical height. We always look for the vertical height. So we're going to get 24 units squared for this one. And then over here again, we can split this up how you guys see it. I split this up into a triangle and a rectangle. So I see my blue rectangle here. Now keep in mind that because this side is 12, I also have this side over here that's 12, okay? Then we have our pink triangle right here. So to find the area of this rectangle, it's just going to be 16 times 12. And to find the area of the triangle, it is 1/2 times the base times the height. Now take a look at this height. Again, I'm adding together the 8 and the 12, and that's where that 20 came from. Okay, so the area of 1/2 times 10 times 20 gives me 100, and 16 times 12 is giving me 192. Therefore, the total area when I add these together is 292 units squared. Okay, so area, making sure you guys remember all your formulas. Next, we're using Pythagorean Theorem. So you guys most commonly know Pythagorean Theorem is a squared plus b squared is equal to c squared. We like to refer to it as leg squared plus leg squared is equal to the hypotenuse squared. So what I like to do is I highlight my right angle and the two sides that are touching the right angle. Those are referred to as the legs. The one side that is not touching the right angle is referred to as the hypotenuse. So from here you guys would plug it in. So leg squared plus leg squared is equal to the hypotenuse 37 squared. Okay, so this is how you guys would plug it in, and I'm trying to use colors so you guys can see this. So in your calculators you would do 22 squared. If you don't have a squared button or you're not comfortable with it, you can do 22 times 22. Okay, should be 484 plus x squared equals, again, 37 squared is the same thing as 37 times 37. So 1,369. Subtract 484 from both sides. This is our standard equation. Subtract 484. X squared, let me shrink this down a little bit. There we go. So x squared is equal to 1,369 minus 484 gives me 885. And then keep in mind, to undo squaring, you have to take the square root of each side. Okay, so you're actually typing in your calculator the square root of 885. Practice doing that now and make sure you're getting the same answer as me. So I got 29.75 approximately. So approximately 29.75 as my missing leg. Okay, come over here, do the same thing. Highlight your right angle. Okay, these are your legs. This is your hypotenuse. So this one's a little bit different because we're finding our hypotenuse. So 42 squared plus 16 squared is equal to x squared. Again, in your calculator, if you don't know where that squared button is, you're doing 42 times 42. So I got 1764 plus 16 times 16, or 16 squared, is 256, equals x squared. These are on the same side together, so you can just simply add them together. So I got 2020. What a year. Take the square root of both sides and we get x is equal to. So again, in your calculator, please practice finding the square root. Make sure you can find it and make sure you're getting the same answer as me. I'm getting approximately 44.94 for the length of my hypotenuse of my right triangle. 13 is talking about zoom factor. So zoom factor is just taking these points and multiplying by whatever they're telling me. So this one is telling me I have to multiply it by 1/2. So I'm at this point right here. I can call this A, and A is at the point 0, 2. When I multiply point A by 1/2, I'm getting A prime, which is 0, 1. Again, 1/2 times 0 is 0, and 1/2 times 2 is 1. So my A prime turns out to be right here. I'm looking for the next point, and let's do this as B. So we'll call this B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So B is at 12, and 1, 2, 3, 4. Okay, so B is at 12, 4. Again, I'm multiplying those by the zoom factor of 1/2. So my B prime ends up being half of 12 is 6, and half of 4 is 2. So 6, 2, I'm going to graph that right now. I'll call that B prime. We have our C value. So you can see I put my tick mark in. I know that C is at 10. 6, 7, 8, 9, 10. So it's at 10, 10. And again, we're taking half of this. So C prime is going to be at half of 10 is 5, and half of 10 is 5. So here's my C prime and my C. And then my last point, point D, which is way up here. D is at 4 on the X, and 10, 11, 12, 13, 14. So again, we're multiplying those by 1/2 to get my D prime. I'm looking at 2, 7. 2, 7. Graph that, call that D prime. And when you connect it, again, it should be the same shape, just a different size. It should be half as big. Look at that. Same shape, just different size, half as large. With the next one, we have a zoom factor of 2. A zoom factor of 2 is going to make it twice as large. So again, this one's a nice graph because it tells me that A is at the point 1, 1. So when I multiply this by 2, A prime is going to be at the point 2, 2. So I'm just going to graph this as A and this as A prime. I have B, which is at the point 4, 1. Multiply that by 2. B prime, 2 times 4 is 8. 2 times 1 is 2. So it's going to be at the point 8, 2. So this B becomes this B prime. So you can see it got twice as large. And the last one is we have C, which is at the point 1, 3. We're going to multiply by 2. We get C prime, which is at the point 2, 6. 2, 6. Call this C prime. Again, connect your points so you can see, look at this. Okay, it's the same. It's still a right triangle, and it's the same shape. It's just a different size. That's what happens with the zoom factor. I'm going to pause this here and make a part 3.